Hello friends, welcome back. Here we are once again, and on YouTube, creative exploring things on creative exploration. Today I want to talk about a new motion LoRA. New motion LoRA by Cseti. Cseti, who also made the basic camera motion LoRA and some other stuff, you know, the drone orbit ones flying backwards, all these cool motion LoRAs, the walking motion LoRAs. They have trained a 32 frame motion LoRA on 70 videos. So, basically to, echoes? Did you say it's echoing? Was my audio messed up? Hope not. Should be normal. All right, well, let me know if it's messed up. I guess I'll keep going. Am I coming through? No, anyway. Sorry, guys. Where were we? Yeah, so they've trained a 32 frame motion LoRA on 70 videos that are 32 frames long. So to put this into perspective, AnimateDiff runs on a 16 frame motion LoRA. So we're running, when you run your animation, it does 16 frames, then it jumps a context window, does another 16 frames, jumps a context window, does another 16 frames. That's a limitation of the actual model itself. What happened here is Cseti managed to figure out, I guess, if they rendered out 32 frame chunks and then trained on 70 of those into one motion LoRA, they've managed to give the motion model some context to get over 32 frames, which means like we can extend our context window from 16 frames to 32, which is twice as long. So it'll be twice as long before there's a flicker or, you know, context change in your animation, which means your animation should be smoother and cooler and more fluid and blah, blah, blah. So you get it from the link in the description. It's the Cseti General Motion LoRA 32 frame SD15 82 version 1. Grab that and throw that in your ComfyUI models folder inside of AnimateDiff motion LoRA. So it goes in there, and then I put it in 32, but put it where you like. So the motion LoRA goes there, and then I'll show you guys how to wire it up and use it. So it's actually really sweet because you just add it to a regular AnimateDiff setup. So let's just do a very quick AnimateDiff setup. Load checkpoint. All right, we're going to load the, it's called Realism by Stable Yogi. I'm going to add the load LoRA here. Load LoRA. Add the V3 adapter to that to smooth things out. We're going to send this model out to a AnimateDiff loader legacy. This will go out to a K sampler. If I'm speed running this, if you want to see how this is all done, go back to my beginner second steps video and you can learn how to set up all this stuff and what it all does. But I'm just going to blast through it real quick because we've all done this a million times. So we need a positive and negative clip. So we're going to grab that from here. We're going to get a clip texting code prompt, and we're going to get 2 of those. So it's going to be our positive and our negative prompt. Clip will go into both of those. They'll run out to positive and negative. Let's turn you green and turn you red. And we know green and red. Yeah. Okay. AnimateDiff is not finished. We need to load the AnimateDiff SD15 text to video model. We are going to set it to LCM greater than square root linear, motion scale of 1.15. And we're going to uncheck the apply models properly. I think. Start there. Okay, so regular context options, we're going to use our looped context options. We're going to set some new values here in a minute. We're also going to grab a sample settings, and we're going to set that to FreeNoise. Okay. So we need to add that motion LoRA we just downloaded. So load AnimateDiff LoRA. You can just apply any of these changes to an already existing AnimateDiff model. It's fine. Any workflow you've already got going. All right, so we're going to grab that Cseti 32 frame motion LoRA. We're going to set the strength to 0.8. Okay, so let's make all this pale blue. These are loaders, so I'll make them green. This is a K-sampler, so we'll make it purple. And we need two more things. We need an empty latent image for the K-sampler, so it knows how big the canvas is. I'm going to set that to 576, 320. Our batch size is how many frames of the animation we're going to do. Since we're testing the 32 frame motion LoRA, let's do 64 frames. Boo, boo, boo. We need a VAE decoder. And we need to set these settings. So we're going to go 11 steps. CFG of 2. We're going to use LCM. And we're going to use SGM uniform. Beautiful. The VAE comes from our checkpoint loader. Everything's wired in. And then we need a video combine on the way out. Video combine. Yep, 24, MP4, 13, save it, sure. Okay, you'll be purple and you'll be red because you're VAE. Okay, so this is a very, very simple, very rudimentary AnimateDiff setup that will just animate a single prompt. So let's add NSFW nude to the negative prompts. And let's add some stuff to this. So we'll say a wave crashing into a wall beside the ocean. And we'll see what we get. Oh, that's the other thing. So because we're using the 32 frame motion LoRA, this actually unlocks the context length in our motion model here to do 32, 1, 8 instead of 4. So instead of 16:14, we're going to do 32:18. So 32 frame context length. It's going to stride 1 per, and then the context overlaps 8 frames. So we're going to get longer, smoother transitions over the course of 8 frames as opposed to over the course of 4. So everything is essentially doubled except for the stride. I mean, because the stride's technically doubled too because it's a 1. All right. Blah, 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 blah. Yeah, that's the whole setup. Let's see what we get. I could have loaded a workflow probably, but I don't know. I feel like sometimes it's good just to go over the steps of building this workflow over and over again so that you really understand all the elements of it, you know. So right now it's rendering. It's going to take about 43 seconds, 47 seconds. And we're using 10 gigabytes of VRAM, but I am also streaming, so yeah, your mileage may vary there. My ticker's off center. It's making me crazy. Let's do that. Oh, that's much better. Much less ticker. Okay. Only 10 what? Look at that. That is great. So this animation would normally, you know, the flickers, the things, the context changes would happen twice as often, basically. So we're getting these nice long context windows, which allows for nice longer animations. And you'll notice with that 8 frame interpolation, even when it even when it cuts, it's very smooth, almost film rife, interpolated style, sort of like breakdown. So this will allow us to make, sort of longer. Oh yeah, 10 gigs of VRAM, but maybe less, maybe 8, because I'm streaming. You might be able to get away with less. Yeah, so okay, so let's try some other stuff. Let's try a kitten walking in a dirty alley, 1978. Flux is not supported. No, there's no AnimateDiff models for Flux yet. But if you're feeling frisky, you can use come on, brain. Deforum with Flux. What is needed to use Flux with AnimateDiff? Models that do not exist yet. Somebody needs to train motion models for Flux, and we need to have AnimateDiff for Flux. And once we have all that, Kasinka has to actually do all the work of making that work. And yeah, we're a ways away from that. Amazing. Yeah, looping context window, we get the cat becomes a cat again. Oh, that's awesome. Okay. Let's try a fire, building on fire. Let's try CCTV footage. I don't know if that'll work, but it's worth a shot. So I'll show you guys what you can do with Flux, which is make your IP adapter images with Flux and then use those in AnimateDiff. Really, for AnimateDiff, you just gotta accept the fact that it lives in SD1.5 land. Some people, like Inner Reflections, have had really good luck doing AnimateDiff and SDXL with like unsampling and all kinds of fun stuff. But the best AnimateDiff motion models are still for 1.5. Yeah, maybe one day there'll be a better motion model for SDXL, but I feel like now that we have Flux, emphasis is probably going to be on training some kind of motion model for Flux, if our machines at home can even infer that kind of stuff. I feel like it would take so long to do a Flux animation that it's just not worth it yet. That nice long transition, that's very cool. And again, I'm doing these super low res just for, speed's sake, so we can get some results. If you start cranking up the resolution and doing your thing, it's going to look amazinger and amazinger. So let's try some stuff. Let's add prompt travel. Let's see how that reacts. We're going to add a batch prompt schedule. Yep. Make that green. We're only going to use the positive prompt from this. And we are going to grab the clip from our LoRA loader. Okay. Maximum frames. Let's do 96, I guess. 3 was 64, 128. So let's do 128. 0, 64, 0, 32, 64, 96, 128. Okay, let me make this a little bigger. Okay, so here's our prompt structure for our animate prompt schedule, prompt batch scheduling, prompt travel. So let's try something. Let's tell a story here. A turkey walks into a convenience store. The turkey takes, this is not going to work. The turkey takes a bunch of cold cuts out of the freezer section. The turkey takes the cold cuts outside. The turkey sells the cold cuts to a man walking down the street, and then we're going to go a turkey walks into a convenience store, and we're going to try and loop this whole thing. Okay, so this is a terrible story. So we're going to try every 32 frames to jump context here and see what happens. So frame 0, a turkey walks into a convenience store. 32, turkey takes a bunch of cold cuts out of the freezer section. 64, he takes the cold cuts outside. 96, he sells the cold cuts to the man walking down the street. And then when it loops around again, turkey's walking back in the convenience store. So hopefully we'll get a loop out of this. 128 frames, that's how long we want to make the animation, and that is a fine size for it. So everything is hunky-dory here. Punch it. Who wants to take bets? This is going to be just absolute nonsense, just turkeys and sandwiches and stuff just flying all over the place. Skate clips, yes, let's do some skate clips after this. That turkey looks like he's walking into a convenience store. New subscriber. Nice. Welcome. Welcome to nonsense. Welcome to chaos. Welcome to this. Whatever you call this. I don't think anyone smart is not betting that it's going to be coherent. But I love to be surprised. £5. All right, here we go. Okay. Oh no, the turkey got cooked. It's cool though how long the context windows are. I mean, normally this would be just so much more chaotic. I mean, it already is chaotic. You know, our story was chaotic, but this is awesome. This is super awesome. So let's try a man skateboarding in autumn. A man skateboarding in winter. Spring. Summer. Back to autumn. Yeah, this poor turkey, he got cooked. That does not look like delicious turkey. At all. Hey, Bill, what's up? It is a loop though. You know, we got that going for us, which is nice. It kind of looks like bread. I feel like KFC would pay me to not advertise this. Yeah, this guy, his pants are invisible. Render. Okay. I can see the seasons kind of changing. I like that they just kind of rock back and forth on the skateboard. The longer context really makes it more hallucinogenic, I think. The transitions being slower like that, you really just kind of, it feels less kinetic and like it's still weird, obviously, and it's still AnimateDiff, but we get more time with each sort of context, which is really cool. So that begs the question, what does a long run with just a simple prompt look like? Let's find out. Man skateboarding down Venice Beach wearing a hat and sunglasses. Let's see if we can do like a long run of this and see how weird it gets. So let's try 240 frames of just one long prompt. Should only take like 2 minutes, maybe 3. A permadosed. Yeah, 2 minutes for 240 frames, not bad. Maybe half that on a 4090. Oh, I think my mic's making awful noises. 1 sec. Hopefully that's better. Do I think there's going to be a version of AnimateDiff for Flux? Yeah, maybe. Do I know anybody training one right now? No. Or if they are, it's a secret. I love how it says it's going to be 2 minutes, but it's actually like 2 minutes and 47 seconds. Like, it doesn't really know. It's just guessing. Yeah, Thrasher Magazine LoRA would be sick. Actually, be a cool idea to train some motion LoRAs on some cool skateboarding footage. See if we can actually train how it works into it. Or like a skateboarding LoRA with like a bunch of videos trained in. Might be interesting. If somebody donate a cluster to me. Whoa! That is so trippy, man. It's like your memories of a day. You know what I mean? Like it's like, I don't know. Like the whole day just ran together in your head. I love sometimes he's on 2 skates, sometimes on like 2 boards with wheels on them, sometimes just barefoot. But he's got a hat on the whole time. That's pretty cool. That's really neat. Okay, let's try some stuff. So if you guys have been watching, you might have seen trying to remember the name of it, the new IP adapter node, the ClipVision Enhanced node. It really helps us get higher fidelity stuff out of lower resolution. Excuse me. Lower resolution stuff. So let's wire that up again. A little refresher course on how that works. So I'm going to put it here-ish. So we're going to grab 2 of these ClipVision Enhancer. Actually, I'm going to start with 1. We're going to add a IP adapter unified loader. Switch it to plus. Plug the IP adapter in. Model comes from the LoRA loader into AnimateDiff. Right? We need to do a little math. We need to do a little math for this. It's easy math. Right click on the ClipVision Enhancer node and go to convert widget to input and change the enhanced tiles to an input. We got to tell it how many. We got to tell it how many tiles we're about to make, and we're going to do some simple math. Primitive integer. Okay, that gives us a number with no decimal place. We need this to do our number of tiles, enhanced tiles. We're going to start with 3 tiles. We're going to add a simple math. Give me a reroute. Simple math. There we go. Okay. The math is A times 224. So IP adapter ClipVision looks at images that are 224 by 224. That's what the prep image for ClipVision node does. It just resizes stuff to 224 by 224. Mateo built a new version of the IP adapter node that looks at tiles of 224 by 224 and then is able to understand that those tiles make up a full image so that we can increase the fidelity at which IP adapters is looking at images, which increases the amount of detail that it's able to pull out, the amount of how much better the prompt is. The long story short is it's a really cool node, and this is worth learning because it's not hard at all. Because all we have to do now is load an image. Kitty in armor. Let me find an image here. Okay, we got this angry fella. We need to resize this image to this number because this is A3 times 224. We need to resize this image to fit it in there and tell it how big the tiles, how many tiles there are, 3. So it's all wired together. So we need to add a node called image scale or upscale image. Change that to center, the crop, and your width and height you're going to turn into inputs. And we're going to get those from our integer. They're going to be the same because this node looks at squares. We're cropping center to a square of 3 times 224 by 3 times 224. All right. All right. All right. All right. So you don't have to do this part, but if you want to, this image negative is going to look at an image that it's trying to get away from. So what you can do is take this original image and use this node called IP adapter noise. And you can tell it whatever kind of noise you want to add. I'm going to add shuffle noise at like about 0.4. feed that into the negative, and I'm actually going to take that from this upscaled image so they're the same size. Okay, so let's grab a preview of what this does so that you can get an idea of sort of what we're trying to push it away from and what we're trying to push it towards. Okay, so that's the image we're sending in, and this will actually, let's preview this one. Preview. Whoops. Try to preview a number. So actually, I'm going to do something even smarter here. I'm going to image concatenate. So that they're side by side. Okay, so we're going to see this image resized beside the image that it's going to be sort of trying to get away from. And we're just going to change our prompt to something super simple. It's 4K. Let's just try 4K. So this should just work if I wired it all up right, which, you know, I might have. I didn't. I forget to plug the model in. I did. I took the model from the wrong place. The model needs to come from here. So it goes into the loader, through the loader, into the node, and out. So there. That's the image it's going to look at, and this is what it's going to try to not make. Oh, also, it does not need to be a 240 frame animation. I think 64 will be fine. Let it jump a context window, see what happens. When you're using IP adapters, your prompt barely matters until you start turning down the IP adapters. So we'll start here, see what it does, and then we'll start adjusting things. Looks like it's got the sort of expression and the position, but I don't know about the clothing and the era. Oh, okay. Creepy. But I mean, for 576 by 320, the quality is pretty insane. All right, how can we make this better? So this prompt sucks, right? It's 4K. This prompt blows. All right, so let's try adding Florence. And you can get these from Kajai's Florence 2 nodes. They're great. They're great. All right. We are going to use the downloaded LoRA Florence 2 model node with the cog Florence model. We're going to plug that into the Florence 2 run. We're going to grab our image from our resized image. Plug that in here, and this thing, if we set it to more detailed caption, change this to an input, plug the caption in, what it's going to do is, I'll make a show text so we can see what it does. But it's going to look at this image, and it's going to give us the most detailed caption that it can of what it sees, and then it's going to use that as our prompt. So hopefully it'll make this a better result. So that's a much better prompt than I would have written. So this is just one of those ways of like not having to prompt. Definitely recommend it. Looks like it's basically making the same image. So that's, you know, our weight is at 1, you know, everything's pretty much filled out. So if you start backing the IP adapter off, the prompt starts to take over. If you crank up the IP adapter, the prompt matters less. You know, play with the settings, do different stuff. So what I can do is copy and paste this video combine, and we can see what the last one looked like when the new one comes up, so we, you know, have an idea. I mean, that's way more like the image. Crazy. I love these shadows in the background. They're crazy looking. Oh, yeah. Yeah. Okay. Let's try a different image. Just going through my nonsense folders here. Yeah, literally. Let's see what it does with, like, I don't know. Let's see if I have something weird. I'll grab an inspiration image. Maybe like this might be cool. I got this off Pinterest or something. Whoa. Cool. So yeah, run these on like stuff you've already made, right? Like you can run all this stuff on runs you've already made. All the images you've ever made are now, you know, fodder for no image to video. All right. Well, that worked good. It's another. Let's try weighted IP adapters. Why not? All right. Let's expand this a bit. This will take me a minute. Basically, I'm making a workflow that'll walk through 4 different images. But I just have to duplicate a bunch of this stuff first. Okay, yep, yep. And one more of these. Image into here, image out. Okay, so now we need image batch multi. Yeah, and we're gonna give it 4 inputs. 1, 2, 3, 4. Okay, and then I'm going to jump over to my folder and grab some images. So inits, desktop, inits. Come on, there they are. Okay, subject. Sure. Let's try some. These are all insane. Sure, let's go crazy. 1, 2. Why not? And this one. This should be a pretty crazy animation. All right. So we're just batching these 4 images together, and we're going to do some stuff with it. But you'll notice I also fed the resolution from our tile thing to all of them so that we can change the resolution by literally just moving this number up and down. And it'll just kind of handle all that through the image scale and then pass into the multi here. So next we need an IP adapter weight node. So this node is going to arrange our batch into 2 different lanes, and then those 2 different lanes are going to go back and forth, and that's how we slide between the images contextually. So we need 1 of these. We need our loader, and we need 2 of these. We're going to plug in our tiles in to both. The model's going to go through and out. Okay. So on these ClipVision Enhancer nodes, we need to use the weights from this IP adapter weight to influence when they change. So we change these weight inputs to weight inputs. So yeah, change weight to an input. And we go weights from the first one and inverted weights from the second one. The total frames is how long the animation is going to be. This is actually going to go into our batch size up here. So we're going to have to change batch size into an input and then grab the total frames from the IP adapter weights node and make that this. That's going to make whatever our final number is the amount of frames for our animation. I'll explain why, I promise. Or not. Maybe I won't. So this image does not come from here anymore. With this image goes in here. Image 1 goes into the first node and image 2 goes into the second node. Oh, you know what? We can't use these nodes. We need IP adapter, ClipVision, Enhancer batch nodes. Batch, we need batches when we're working with batches. We need batch nodes. Okay. So plug IP adapter into both of these. Model comes through them and out. Okay. So it would be like that if you were to look at it. 1, 2, 3. Badoop, badoop. All right. Same stuff. Weights into the first one. Oh, no, we got to change you into an input. Weights from the first one. Inverted weights to the second one. Image 1 to the first one. Image 2 to the second one. I'm going to leave negatives off for now. You can do that whole situation I built before if you want. You don't have to. We're going to have to also add the enhanced tiles. So we're going to turn those into inputs. Because it needs to know how many times it's being multiplied. In this case, 3. All right, weights, batch. I think that's basically everything. So what we want to do now is set the frames. This is how long it's going to sit on each image. So we're going to go 32 frames for each image. We're going to add 16 frames at the beginning and 16 frames at the end, and switch it to alternate batches. So let's visualize what this is about to do. stage 2. Video combine 24 MP4 save off. Okay. So that got a little complicated, but we're here now. Okay. 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 Actually, you can probably use an output too. Preview. Yeah. Okay, is anybody confused? I'm trying to figure out. There we go. Yeah, this workflow got a little confusing. Okay, so what we're doing now is we've made a batch of these 4 images. Bop, 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 bop. It's going to use the IP adapter waits node to make a alternating batch of those, and then it's going to do an animation where it's sort of switching between those images. And if I did everything right, it's going to pull the prompt from this first image. So why don't we disable that and change it back into a thing and just say 4K, because we're going to let the IP adapters do all the heavy lifting here. Just make sure everything's plugged in. Looks good to me. Yeah. So you see how it sort of, this is what the IP adapter waits node does here. Makes this sort of batch. This is running at 24 frames per second, so they're just sort of switching over time, and then as those batches feed through, it'll switch up the contexts in time in the animation. Batch nodes take a little while to load. Plus 32 times 4. It should be a pretty quick animation. It's happening. So 128 frames. Cool. Not bad. All right. Whoa. Crazy. You're definitely getting those 32 frame context windows. And again, like I'm doing 576 by 320, so you can imagine how this scales up once you start doing higher resolutions. Gets rid of a lot of that dotty, pixelated nonsense as you start going up. Yeah. Man, so we covered building out an IP adapter workflow, build up prompt travel workflow, regular prompt workflow, and a weighted IP adapters workflow, all on the 32 frame motion LoRA. So yeah, if you need a refresher on any of this stuff, this might be the video to come back to for setup and stuff like that. I might chop up some stuff for the ClipVision Enhanced nodes and stuff to make some little shorts. But yeah, as you guys can imagine, this goes pretty deep. So play with motion LoRAs, start training your own, train stuff, make stuff, show it to me. I want to see it. Tag me, hit up the Patreon, hit up all the other stuff. I'm going to end it here because this is great and everything's chill. And that was really fast. We got through it really quick. So thanks, everybody. Go forth and play with the 32 frame motion LoRA. The link is in the description below. And just remember 3218 is the default settings to get started. And then you can lower that overlap window if you want quicker cuts. And you could even try increasing it too. I haven't tried increasing it. It might work to make that overlap even longer. So yeah, go forth, play. Let me know what you find. Come to Discord. Come to the Patreon, Pers.xyz for all the links. Pers loves you. We'll see y'all real soon. My next guest is a surprise, but I'll announce them real soon. Bye-bye.